So how do we make the left side equal the right side of this problem? Well, when I look at this problem, and remember we've learned last week that there's multiple ways to achieve this, and sometimes the way that makes sense to me initially is not the fastest way. And both Fabian and Miguel have been able to demonstrate, and Mara have been able to demonstrate different ways to achieve the same answer in a more efficient manner. So again, I may do it in a different manner than you do. As long as you are using trig identities, you should be okay. So whenever I see a function that is squared, I immediately look over here to see, can I use one of these? So can I translate one of the trig identities where secant squared theta minus 1 is shown? So here's secant squared theta. So I would need to subtract 1 to the right-hand side, and then I could replace secant squared theta minus 1 with tangent squared. So I'm going to come up here and write tangent squared theta over secant squared theta. Now I know that tangent squared is the same as sine squared over cosine squared. And I'm going to divide this by the secant squared. When we do division, I should write the entire statement out. When we do division, I'm going to turn division into multiplying, and I'm going to flip it. I think I have a little more room over here. So now on top, I can multiply straight across. I have sine squared theta, because sine squared times 1 is just still sine squared theta. On the bottom, I have cosine squared theta. Now, before I write down secant squared theta right next to it, a couple different things. And there's two different ways that I can think of in my head that I could write this. When I write secant squared theta on the bottom, notice that secant and cosecant are simply reciprocals of one another. So if I move secant up to the top from the bottom to the top, then I'm able to translate it into a cosine. So instead of me writing secant here on the bottom, I'm going to move the secant squared up to the top, which makes it a cosine squared. And now we can easily cancel these out. Remember, they are going to be reduced down to 1, and I'm left with a sine squared theta on the left, and that is equal to a sine squared theta on the right. Anybody that is with me, can you please put your name into the chat at this time? And then please do me a favor. I'm going to grab my phone, which has not died. And nobody else watching this will be able to see your responses in terms of what you rate yourself with this. But can you, as I look at this, can you please give me into the chat? Give me a 1, 2, or 3 based on your understanding. 3 is the highest, 1 is the lowest, 2 is somewhat in between. And then we'll move on to question number 2. This is being recorded, so if you work best by just watching it, and I will put it out for everybody else to watch at a later time that's not with us. If you work best by writing it down, then do that way. Okay, I'm going to give you a chance to write down the second example. In the second example, our goal is to combine fractions before we use trig identities to show the left side is equal to the right side. I had a student last week that said, when you will use the McFarland method, is that different than the butterfly method? They're the same concepts, just different terms. So unfortunately, these are not exactly the same. One is addition and one is subtraction. So for me to combine the left-hand side, I'm going to do what I call the butterfly method. It's the same thing as the McFarland method. But what I did see students doing last week that was wrong is sometimes they started, let me make sure that's clear. Sometimes they started on the right and went down, and then they followed that up by going the left on. You always have to start top left down to the bottom right. So 1 times this quantity is simply 1 plus the sine of x. Now I bring down the symbol and I do the bottom left up to the top right, multiplying. I'm left with 1 minus the sine of x. And then I push together 1 plus sine of x times 1 minus sine of x. On top, I simply have 4 different terms. Let's see what we can combine. So I have 1 plus 1 is 2, so I'm left with 2, and a positive sine of x and a negative sine of x. They're additive inverses. They simply cancel out. Now on the bottom, I would generally tell you to FOIL this. But notice how the fronts are the same and the backs are the same, and the only difference is the sign in between the two groups. When that happens, we get to save ourselves times. We don't have to do the O or the I because they will cancel each other out. And if you didn't realize that, let me do all 4 steps and show you how you can cancel out. Fronts would give you 1. Outside is a positive sign of X. Inside is a negative sign of X. And when I multiply the last, I have a negative times a positive is a negative, and sine times sine is sine squared. This will always happen when both parentheses are exactly the same except for the sign in between the two groups. The two middles, the O and the I of FOIL, you don't have to do because they are always opposite of one another. So on the bottom, I'm left with 1 minus sine squared. Okay, anytime I get a function that is squared, I immediately think, oh, I wonder what I can do with the trig identities. So 1 minus sine squared, some of you are getting really good at this. 1 minus sine squared. So if I take a positive sine squared and I move it to the right-hand side, it becomes negative. 1 minus sine squared is equivalent to cosine squared. This is the same as 2 over cosine. Oops, so sorry. Let me move it up. 2 over cosine squared x. Now, our goal is for this to equal 2 secant squared. Well, when this moves from the bottom up to the top, remember that secant and cosine are reciprocals. So if it's a cosine and I move it up, then I change it to its reciprocal secant. So this is equivalent to 2 over, it moves up, which would be secant squared, and now it's equal to the right-hand side, which is 2 secant squared. Do me a favor again, for those that are with me, thank you for joining. Give me again a 1, 2, or 3, 3 being the highest, 1 being the lowest. Your understanding of this problem. It's okay to be a 1, it's okay to be a 2. Right. This is a third example. And I got a book from the bookstore that I could use here. That was the pre-calculus book that was used on our campus probably 15 years ago, but math doesn't change. Math is the same. Okay, and so in this problem, our goal for this problem is to verify the trig identity. So it's just like the first example that we went through. So I'm looking at this problem. I see the 2 parentheses. I'm going to give you a chance to write it down before I get going. But while you're doing that, if you're not writing down, I see squareds, and so I'm focusing on what can I do with these? What can I replace them with? Okay, so here we go. Hopefully you get a chance to write this down. I'm going to locate the tangent squared. Okay, tangent squared theta plus 1. By the way, tangent squared x plus 1, it's the same thing. This just represents this angle. So tangent squared theta plus 1 is equal to secant squared theta. I'm able to take this exact same part of the equation and I'm able to replace it with secant squared x. Now cosine squared x minus 1. So in order for me to do that, instead of verbalizing it, I'm going to come off the side here and I'm going to rewrite this original, the most common trig identity. I'm going to rewrite it so that it says cosine squared x minus 1. So I'm going to remain having the cosine on the left-hand side, and I'm going to take the 1 and move it to the left. Opposite of a positive 1 is a negative 1, so I have nothing left over here, and I have sine squared plus cosine squared minus 1. Now I want to isolate this portion, and so now I need to subtract the sine squared. So cosine squared x minus 1 equals negative sine squared. It's almost like we're teaching talking a different language without this trig. So I can replace this portion with a negative sine squared. Okay, so at this point, I'm recognizing that I know tangent is, forget about it being squared. I know tangent is the same as sine over cosine, sine over cosine. So I already have a sine, and I know that secant is the same as the reciprocal of 1 over cosine. That means if I take secant and I move it down below, right now it's up top with the sine. If I move it down below, then I have to change it into its reciprocal. So I'm able to rewrite this as negative sine squared x, I move it to the bottom, over cosine squared. All right, and so mathematically how we do this is we do sine of x over cosine of x squared, which is tangent squared. And here's where you have a negative tangent squared x equals negative tangent squared x. That one's a little more difficult. And where I think a lot of students would make a mistake is I think they would replace this portion with simply just a sine squared x and forget about the negative sign when we rewrote it. Okay, one more time, please go into the chat. This time, give me a thumbs up or thumbs down if that made sense to you. Our next problem is going to be converting sines and cosines. And so I think this is a pretty easy problem. Again, I've looked over the first 6, and I wrote down 3 more problems after the first 6. We can even do a few more after that if you choose. But I know that when I go through problems 7, 8, and 9 as examples, I have not even looked them over yet. So you'll be doing those with me at the same time and having that initial thought process. Okay, converting sines and cosines for example number 4. So what we have to know here, and again, all of these as a reminder, these will have to be memorized. Now for your test, I will provide these to you on the board on Tuesday. I will provide these for you. But over the course of the next 2 months, we need to have these memorized. Really, our goal is by the middle of April is for us to have this memorized. Not only sine squared plus cosine squared equals 1. That's the first thing I would do when I got to my AP test. I'd have these memorized and I'd write them down. And then from there, we can easily translate it into things like cosine squared equals 1 minus sine squared and whatnot. Okay, so what is tangent equal to? It's equal to the sine of x over the cosine of x. And what is cotangent equal to? Cotangent is equal to the cosine of x over the sine of x. And now for us to combine these, we would have to have a common denominator. So we're going to use that Macfarlane method or butterfly method. Always go top left down to bottom right. So I have sine squared plus bottom left up cosine squared. And on the bottom, we're going to do cosine of x times the sine of x. And we want this to equal secant of x times the cosecant of x. Okay, anytime I have a trig function that's squared, I'm thinking to myself, is it possible to translate this into one of our trig identities? And we can see the most common one is sine squared x plus cosine squared x equals 1. So this portion now can be rewritten as 1 over the cosine of x times the sine of x. And as I've spoken about in our previous examples, that when I take a trig function, these are primary trig functions, cosine, sine, tangent, those are the primary trig functions. And the reciprocals, cosecant, secant, and cotangent are the secondary ones. So if I take a trig function and I move it from the bottom to the top or the top to the bottom, then I need to rewrite it with its reciprocals. So cosine is going to change. Where's my cosine? Cosine is going to change to secant, and sine is going to change to cosecant. It comes up top, it changes into secant, that's an x. Comes up top, it changes into cosecant. And now the left side equals the right side. Let me pull up my phone here before it dies. One more time, do me a favor, can you give me a thumbs up in the chat or a thumbs down based right now on your understanding of these problems I've done, specifically this problem, which would be example number 4. Welcome, Johnny, glad you could join us. Thank you for the feedback. All right. Thank you, Bree, Maro, and Joshua for the feedback. I'm going to give you a chance to write down example number 5. Like examples 1 and 3 that I provided, example 5 is verifying a trig identity. And what may cause a little bit of problems here, we can start on the left or we can start on the right. And if you've come in a little late, I shared at the very beginning that just because I can achieve the answer doesn't mean that I'm showing you the most efficient way. It's just the way that my brain was able to achieve it. And we were able to see that last week when several of your peers were able to achieve the same answer, but definitely in a more efficient way. So as I go through some of these harder problems, if you see an easier way and you'd like to share it, we'll put it here on this video so others can see multiple ways. So what I think is different about example number 5 is that none of these can immediately be applied because each one of the trig functions within these identities is squared, and none of these are squared. So what could we do to square it? Well, I have a couple different thoughts. One thought is, could we go ahead and could we multiply by the reciprocal of sorry, not the reciprocal, could we multiply by the conjugate of this, which would be secant of x minus tangent of x. Yeah, we probably could do that. Or here, can we multiply by 1 plus the sine of x? And I think that's probably the route I'm going to do. Remember that if you're going to multiply by the conjugate, whether it's the conjugate of the numerator or the denominator, it must be multiplied by the top and by the bottom. And the reason for that is when you have the exact quantity divided by the exact same quantity, this is the equivalent to 1. And taking 1 times this amount, it doesn't change this amount. Now, if I only multiply the denominator by the conjugate, it would change this original value of this fraction. Okay, let's get started. So right now I'm going to see, can I prove that the right side equals the left side? I'm going to multiply to get cosine of x plus cosine of x times sine of x. Remember what I spoke about in a previous example today, and we've talked about it in the class in the last couple of weeks. When you have the exact same quantities, the only difference is the sign. I only need to do the front and the last. The two middle, we can be eliminated. So 1 times 1 is 1. The negative sign times the positive sign is negative sine squared theta. Now I finally have a function that is squared. So I'm going to come back over here. And how could I rewrite this first identity to equal 1 minus sine squared? Well, I'd have to take this sine squared and move it to the right-hand side by subtracting, because opposite of positive is a negative. So 1 subtract sine squared would be equivalent to cosine squared. I'm going to rewrite this as cosine of x plus cosine of x sine of x all over cosine squared x. I don't want to go too fast. Okay, different ways to go about doing this. The way that makes most sense to me, is I see that I can pull out a cosine on top. And I recognize that cosine squared is the same as cosine of x times cosine of x. So this is just taking and expanding it. So I'm going to take this and rewrite it like this. Cosine of x times cosine of x is cosine squared. Why am I doing this? Cosine of x times 1 is cosine of x. Cosine of x times sine of x is cosine sine. And now because we're only multiplying here, I'm multiplying the quantity on the left times the quantity on the right. Quantity on the left times the quantity on the right. I am able to reduce these simplify down to 1. And now I am looking at 1 plus the sine of x over the cosine of x. This has to be shared with both the left and with the right-hand sides. So 1 over cosine of x, it's not very neat. 1 over cosine of x plus sine of x over cosine of x. Now 1 over cosine, remember when I take that cosine and move it up to the top, I'm going to have to write the reciprocal. So this is going to be secant of x, and then we know sine over cosine is tangent of x. And now the left side equals the right side, or in this case, the right side equals the left side. Hey, go into the chat. Please write yes if you have any questions, and then I'll wait for you to turn on your mic and answer. Write no if you feel like you have a good understanding of that problem. Yes, I will pause, answer any questions you have. All right. Maro, which question do you have, or do you see an easier way that you'd prefer to do this?
Okay, Ms. Bradley, so I did it a different way.
Yep,
but I don't know if it's right.
Well, let's practice. Did you start this way or did you start on the left-hand side?
I started on the left.
Okay, let's do it. Do you mind if I rewrite the problem?
Yeah.
Okay. I was pretty sloppy there. Let me go back 1 second to make sure that I correctly wrote that down. Okay, I did. Tell me what you did. I'll write down step by step. And if I see any mathematical mistakes, then we'll stop and talk about
Okay,
it.
yeah. Okay, so I butterflied the left side, so I did
Okay, so you're
secant
gonna
is
do,
just 1 over cosine, yeah.
yep. Okay, so 1 over the cosine plus
Plus
sine over the cosine.
cosine, yeah. So I got cosine plus
Okay, so you have cosine.
cosine,
Okay, all
yeah,
right. Okay, so actually, okay, so you have cosine of x
plus,
plus
oh yeah,
cosine sine of x over
over cosine
cosine.
squared.
Yeah.
And cosine squared, I just rewrote that as 1 minus sine squared.
Okay, hold on 1 second.
Yeah.
Cosine of x plus cosine sine of x. This is 1 minus the sine squared x. Okay.
And then I factored by a cosine on top, so I had cosine times 1 plus sine.
Okay, keep going. I see your thought
Yeah,
process here.
yeah,
Hold
and
on one
then
second. Give me 1 second.
yeah,
It's one of my children.
yeah,
Benjamin, Naomi, can you wait for me to get done tutoring and then I'll come help you with whatever you need? You can go talk to daddy. Go find him in the house. Okay, I'm ready.
yeah, and then you have 1 minus sine squared. So to get that, you need to have 1 plus sine squared and then 1 minus sine squared, and I just canceled out the 1 plus sine squared.
Love it. Yeah, that's how your mind sees it, and that's exactly what this was equal to up here.
Yeah.
Absolutely, that's an alternative to doing it. Nice job. Very
All
nice,
right.
very nice thought, Maro.
Yeah. Thank you, Riley.
Yeah, I love it. I think that trig identities allow for more creativity, again, because there is more than one way to do this. Thank you for sharing that. Okay, let's go on right now. Does anybody else? So I've not heard from, there's 4 of the people with me. Can you give me a yes or no if you have any questions? And no is I'm good to move on. A yes is we'll stop and wait for you. This is example number 6. I'll give you a chance to write it down. And in this problem, we are going to show how it's the most difficult of the 6 problems. And we're going to show how we're going to work with both sides. And we're going to do that, I believe, separately as when I look this over. I'm going to give you right now 1 minute to start on this problem and see where you go with this without my help. And then I'll begin. Okay, so that was about 1 minute. Here is my question. So for those that are with me, I don't care about right or wrong answers. Which side were you drawn to feel like I'm going to start on this side? Like, for instance, on the last problem, I started on the right-hand side and I was able to achieve the correct answer, proving the 2 sides are equal. And Maro started on the left side for the last problem. What side are you drawn to start on and why? So, and you can put, I don't know. So go into the chat and tell me, do you feel like you're drawn? Like, I think I'm going to start on the left side, or I think I'm going to start on the right side, or I don't know which side I should start on. Go into the chat, please give me an answer. When I see this particular problem, I only see one trig function that is squared. And so for that reason, I'm going to come over here and I'm going to locate cotangent squared. So here's our cotangent squared. And if I want to isolate the cotangent squared, I've got to move 1 to the other side. So cotangent squared is equivalent to cosecant squared minus 1. So in this position, I'm going to replace this with cosecant squared minus 1. Okay, now these look really similar, but they're not the same. If we go back to what, let's see if I can find really quickly the paper I used for Maro. That would be helpful. This is what we did with Maro. So Maro recognized that 1 minus sine squared x is the same as 1 plus sine of x and 1 minus sine of x. Not everybody sees that. I want to give you a quick example here. If I said x squared minus 4, you would recognize that's x plus 2 and x minus 2, hopefully. Well, 4 minus x squared is the same concept. It'd be 2 plus x and 2 minus x. If you FOILed this out, front, outside, inside, last, and you were able to simplify it, you'd get this. The same thing. If you FOILed this out, you'd end up with this. So Marlon did that here. The ones will go in front, the signs going back, one's positive and one's negative. I'm going to do this same concept up here. So I'm going to break this into the cosecant of x plus 1 and the cosecant of x minus 1. Notice they're exactly the same, just one's addition and one's subtraction. So I'm multiplying the fronts and multiplying the backs. On the bottom, I have 1 plus the cosecant of x. Now, can I eliminate? By eliminate is they're exactly the same quantity to the top that's on the bottom. These two are exactly the same, although they're not in the same order. An example, we know that x plus 4 is the same as 4 plus x. They're the exact same thing. When you add and you can change the order of what you're adding, you get the exact same answer. So these two are exactly the same, whether you write cosecant of x plus 1 or 1 plus the cosecant of x. That means that they're going to be eliminated. In reality, they are reduced down to 1, and I'm left with the cosecant of x minus 1. But that still doesn't equal the right-hand side. So in this problem, I need to share this with the left, and I need to share this with the right. So I have 1 over the sine of x, bring down the subtraction sign, and then sine of x over sine of x. This has to be equally shared with the left and the right. Whatever is separated, the sign separated by, in this case, the subtraction, shared with the left and the right. 1 over the sine, well, if I bring sine up to the top, it becomes its reciprocal, which is the cosecant. And when you have the exact same quantities divided, you end up with 1. Now the left side equals the right side. For those that are still with me, can you give me a 1, 2, or 3 based on your understanding of this particular problem? 1, 2, or 3, please. I have 3 more problems, and then I'm going to stop for you unless somebody else has questions. I have not looked any of these over, so you'd be doing them at the exact same time that I am. But here's the very first problem. I'm going to give you a chance to write it down. And whether we start on the left side here or we start on the right side, it's really up to you. But you know what? Let's go 45 seconds to see what you can achieve with this problem, and then I will begin. So I don't want to distribute through a negative sign. I'm going to replace cosine squared with 1 subtract sine squared. Cosine is going to be 1 subtract sine squared. So 1 subtract sine squared x minus sine squared x equals 1 subtract 2 sine squared of x. So 1 minus sine squared x minus sine squared x. So I have 1, and then I have 2 groups of a negative 1 sine of x, negative 1 sine of x. So there's 2 groups. Now the left side is equal to the right side. 2 left. Is that the exact same one? No, it's just slightly different with this one. Okay, again, I'm going to give you a chance to write it down. And then I want to give you 45 seconds to see if you can complete it. We are almost done. Hang tight. Now, in this particular problem, notice that I chose to replace cosine with 1 minus sine squared. And the reason for that is if I replace sine in the previous problem, sine would be 1 minus cosine squared. And I could do that, but I wouldn't want to rewrite this in terms of cosine because notice on the right-hand side, it was sine. That's why I replaced cosine with 1 minus sine squared. Then I was only working with sines, and I knew that's what I wanted to achieve. Excuse me, in example number 8, I want to achieve cosines. So I'm going to replace the sine. Sine squared is equal to, and then let me look over here, is 1 minus cosine squared. So I have cosine of x, distribute minus 1, distribute, a negative times a negative is a positive. Messed up there. And now I have cosine and cosine. I have 2 cosine squares x minus 1. And now the left side is equal to the right. For those that are with me, I have 1 left to do. Give me right now your overall your overall confidence with what we've done. Give me a thumbs up or a thumbs down based on your overall confidence before we try our last problem. Okay, here's your last one. I'm not going to give you any helpful hints. Let's see what you can do. Some of you may be done with this in 10 seconds. Don't say the answer, but when you're done, can you please go into the chat and just write the word done? Just a reminder, as soon as you're done with this problem, go into the chat and simply write done. So I want the left side to equal the right side. And as I'm sitting here and waiting for you to finish, I can think of like 3 different ways that we can do this. But my first instinct, instead of showing you all 3 ways, and I'm going to ask students if they did it a different way, was that I know that tangent squared is equivalent to secant squared minus 1. And I see a secant over here, secant squared, in fact. So I'm going to replace tangent squared with secant squared minus 1. Secant squared x minus 1 plus 6 equals secant squared x plus 5. Okay, a -1 and a positive 6 is a positive 5. And now I have secant squared x plus 5 equals secant squared x plus 5. The left side is equal to the right-hand side, and we're done. Does anybody have questions about that? Anybody else? I will put up 4 more problems on Monday. When I'm correcting tests, I'll put up 4 more practice problems that you guys can review. If you have any questions, remember I have attached not a video for part 1 of the review, but I did attach the answer key, and I have videos for part 2 and part 3. You do have your tests on Monday. Once again, I will write these on the board. Thank you for joining me today. I will place this recording on the teacher website. If nobody has any other questions, I'm going to end today.